All right, welcome back, everybody. We are going to get going with part 2 on matter. So the last time we were talking about this stuff, we basically defined what matter was and all the different ways and shapes that we see matter, right? Like solid, liquid, gas. Right? I mean, that's how we find it. We find it in pure substances, and we find it in mixtures. And in mixtures, there's definitely more than one kind. We have heterogeneous and we have homogeneous. And the same thing with substances. We have both elements and compounds. So there's like the two versions, for each. And also, not for nothing, mixtures, they can be separated and stuff. Remember, like you got chromatography, filtration. My faves. I love me some filtration. What was it? Oh yeah, filtration, chromatography, distillation, and crystallization, right? So that's how we can separate mixtures, whether they're heterogeneous or homogeneous. And we also talked about pure substances, right? Like a substance is like one thing. It's even. It's like always the same. It's all one thing. And substances come in two kinds. We have, what did we say we have? Oh yeah, elements and compounds. Those are the two basic kind of substances that we're going to tell. And how do we tell everything apart? With their chemical and physical properties. Totally. So what we're going to do today is we're going to dive deep and dig into substances. That's what today is. We're going to look into we're going to look at substances and how it sort of splits, like the two different versions of substances, elements and compounds. We're really going to put a fine detail on those two words, elements and compounds. That is our goal for today. That's like what we're going to do. So, giddy up. Time for some learning. You ready? Okay. So there's me in the corner. So here we go. Substances. Oops. Hold on. Let me get my little fancy pen thing going on here. There. Oh, there it is. Oh, wait. There. Oh, there. There she is. Okay. So a substance, it is, like we said, it's basically anything that's like the same all throughout, right? And there are two kinds. There are elements and compounds. Now, the easiest one for us to talk about is going to be an element. Because an element is the purest substance, okay? Like these little bubbles over here are kind of like, I'm drawing these so that they look like the same, right? So this is like red element, right? Sometimes they show up at two atoms at the same time. Sometimes they show up as like three atoms at the same time. Some very few, but sometimes you get like just one atom at a time. That can happen. But if you notice, red element is red, right? All the atoms are exactly the same. Circle, let's call it circle, a circle element. Circle element is a circle, right? It's all the same. Same with this guy. Each one of the atoms is exactly alike. We cannot tell the difference, right, between one atom and the next atom. That's how we know that sample represents an element, because you can't break it down by chemical or physical means, right? If everything is just one kind of atom, man, how you gonna break that down anymore? Like you can't break down a single atom chemically or physically, because by breaking something down chemically, you're either breaking or making chemical bonds. Well, I guess you're breaking it down, you're breaking chemical bonds, right? Yeah. You understand what I'm saying? So we can't break it down, we can't purify it. That's just all there is to it, because each atom is exactly identical. Also, each atom has its own unique name and symbol, right? Like if it's copper, which seems to be my favorite symbol du jour recently, copper is Cu. Iron is Fe. Oxygen is O. Francium is Fr. Right? These are just the symbols that have been given to the elements over time, and they are captured on the periodic table, and it organizes them by similar properties. And we're going to spend a whole chapter looking at the properties of atoms and how that dictates the shape of the periodic table. Right, so the periodic table is all weird shaped because atoms and elements, man, they're weird. But that's what an element is, right? Basically all the same atom. Very pure. It's the purest substance you can get. Now, the next thing is a compound. I guess instead of red, we have dots. We have circles and dots. Now, a compound is made out of elements, right? So a compound, just like a compound word is like two words stuck together that make one. A compound is more than one element stuck together to make a new thing, to make a new substance, right? But here's the deal: is that they have to be chemically combined. All right. So if they're not chemically combined, they are technically not allowed to be a compound. that would be a mixture, right? So weird things happen when we chemically combine things, okay? And the electrons get all rearranged and they form these things called chemical bonds, right? And it's literally what holds atoms together. That's what chemical bonds are. It's why, I don't know, when you hold your arm out like this, it doesn't just fall off because there's all kinds of chemical bonds holding it together. It's why this pen stays together as a pen. There are chemical bonds holding it all together. And now the thing that's really weird about this is that when a chemical bond is made, right, like you get two pieces, you put those two pieces together with a chemical bond, the product, or the thing that is produced, the new compound, is like wicked, totally, utterly different than the elements that they started with. Like it's like not even close. Okay, so like I think the example that I used yesterday, or in the other video, it was like hydrogen and oxygen, both incredibly flammable, but you put them together and you get water, and water puts out fires. So, right. The other thing that I like to talk about, and we're going to be looking at this a little bit later with like chemical bonds and ions and all that good stuff, is sodium and chlorine. Sodium is a metal, but in the elemental form, it's actually a metal. I have some, and we're going to like put it in water and see what happens. It's a beautiful, shiny silver metal, very soft. You can cut it with a butter knife. And chlorine is in elemental form. Chlorine is a noxious gas. It's sort of like a weird, yellowy, greenish kind of color. So if you took a piece of sodium and you ate it like a little teeny piece like this, pop it in your mouth, if you could manage to swallow it down, it would be a lot like swallowing a grenade. Like you're literally going to explode from the inside out. It's actually it's like sodium's pretty wild. It explodes if you put it in water, which makes it kind of awesome. On the other side, you got chlorine. Now, chlorine is this noxious gas, and it is what we often call incompatible with life. It's bad, man. Chlorine, you get one huff of chlorine gas, and that's probably all you get, and then like lights out. However, if you waft chlorine gas over sodium, a chemical reaction happens spontaneously, big lots of light and heat, and you're left with a white, like, crystalline powder. And we put that on our French fries because it's table salt. So table salt is delicious. We can eat it. We need it to stay alive, but in its elemental forms, it will one of the pieces will kill us. The other pieces would be like eating a grenade. So yeah, when I say different, dude, I mean like really, really different. You know what I'm saying? How's that chemistry cat? Who doesn't like a good meme once in a while? Especially when they're old and outdated like this one, like me. So, chemistry cat. Two men walk into a bar. One man, chemists. Let's make them chemists. Because, yeah. Two chemists walked into a bar. One chemist said, I'll have some H2O. The second man, chemist, said, I'll have H2O too. The second chemist died. Get it? Get it? Look, see, because H2O is water and H2O2 is hydrogen peroxide. Get it? See how they have different chemical formulas? See how they're like different? Do you see that? Is it just me? Yeah, I don't care. I thought it was funny. I'm a dad, so I'm allowed to laugh at those jokes. Okay. So, also, not for nothing, I want you to pay attention to that, right? And you guys seem to have like some kind of modicum of like intelligence because you're kind of picking up there, like without even knowing it, that H2O is different than H2O2, right? You guys see that? You guys see how that makes that joke funny? H2O, H2O2, they are different things, right? Lock into that because that's a fundamental law of nature that we're going to talk about later, right? So, particle diagrams. Why do we have particle diagrams? Because you're in school and they have to find some way to give standardized tests. So here we go. We have particle diagrams. And also it does sort of help like hammer home the idea. Oh, and also, look, man, question time. Which particle diagram represents a sample of one compound only? Dude, listen. Every homework assignment y'all see in my class is going to be geared from or tweaked by some kind of like Regents-based question, right? There's like Regents I think might even be older than me, which is significant oldness. So, there's a lot of Regents questions to dig from. But look, they all have the same basic format. And what I need you to start doing is anytime you look at one of my questions, whether it's on a test, a quiz, or a homework, you got to start looking for the buzzwords, right? Like the vocabs. Because look, let's go purpley color. Which particle diagram represents the same? Look, there it is. You see that right there? That is your vocab word. Okay? So before you go answering anything, look at what the vocab words are in the question, right? Because they're basically saying which particle diagram represents, that's supposed to be a sample of one compound only. Dude, that's a vocab word. This is a picture version of a vocab question. You got it? Okay, so let's go. A compound is two or more elements chemically combined. Two or more elements. Look here. I have dot and circle. That's dot and circle. So these are the same. Dot, circle, circle. Oh, I guess these are the same compound. This is one compound. This is a different compound up here, right? Right, because they're made of it. But this is 1, 2, 3 different. Do you see how they have different atoms, right? This is a dot atom. This is a circle atom, and they're chemically combined. That's why they're touching together. They're together, right? So that's how we know that that's a compound. Lock that inside your little little bean there. Okay, let's go down here. Now the question is, one compound only. Well, if I look here, I've got circle, circle. That does not inspire me to be much different. Circle, this all looks like it's circle. Oh, it even says over here, one atom of one element, atom of another element. All right, well, that's easy. So if I go to the next one, this one here, look, I've got circle, circle. This is all the same. This is the same. So remember, elements you can have more than one atom of one element. So this looks like one element. This looks like dot and a dot. Dude, this is like just a different element, right? Because this is element 1. And this over here, this is just element 2. And they're not chemically combined. So there are two different elements in here. We have this element and we have this element. But bud, those things are not the same, right? Because they're just, I don't know what to say. They are just not, right? Okay, let's go down to this one. Well, they're not chemically combined. That's why not. One compound only. Okay, because I wanted to make sure that, because here I see circle and here I see dot, here I see circle. So it's circle, circle, dot. Man, this is a compound. Totally, right? Circle, dot, compound. Right? Circle, dot, compound. Circle, circle, dot, compound. But these are two different compounds. You get what I'm saying? This is circle, circle, dot. That's circle, dot, right? Just like H2O and H2O2, right? Hydrogen peroxide. Stuff you get in the store is really cute and fine. But man, hydrogen peroxide is one of the nastiest things I have ever come across. I am actually afraid of hydrogen peroxide. That's stuff you get in the store. But like you start getting up into 30, 40, 50% hydrogen peroxide, dude, just leave the room. Just get out. Just leave. It's nasty. Anyway, let's go on to sample number 4 here. Sample number 4, we've got circle and we've got a dot. We've got a circle and we've got a dot. Look, compound. Apparently, I can't write the word and sing it at the same time. Look, circle, dot, circle, dot, circle, dot, circle, dot, circle, dot. Can I keep this nice and clear for you so that you can see what I'm writing? Dude, they're all circles and dots. So here's my answer. Right? Because they're all circles and dots. So they have, this thing is made out of two different elements and they're combined. So and the ratio, right? I guess that's the word I'm looking for. Like the number of circles and dots in each one is the same. So that's what makes these all the same compound, because the ratio. Remember H2O, H2O2. Remember I told you you're gonna need that? I'm not kidding. I don't lie. Often to your face. So look, this what I was talking about, H2O and H2O2, and this thing with like circle, circle, dot, and circle, dot, these two guys up here. It's this thing. It's the law of definite proportions. And it's like an intuitive thing that you guys kind of already know just by like being around and alive. But here it is, codified into an official vocab word. This says that compounds are always composed of the same elements in the same proportions by mass. You can also say by this, and like compounds are always composed of the same elements in the same ratio. So this thing right here, this like proportion by mass, this is like another way of saying ratio. Okay? The only thing is that we say proportion by mass because this is what we can actually measure in the lab, right? We can't we can't pick up a compound and be like, oh, there's 2 hydrogens and 1 oxygen. Man, they're too stinking small. Like, the size of an atom is like mind-bogglingly small. So proportion by mass just means ratio. You guys already know that because, y'all pretty smart. Ooh, draw a particle diagram for an element. Here's a question. There's my vocab word. The next one says, draw a particle diagram for, a pure substance. Nice. Let's go to the next one. A pure substance. Draw a particle diagram for a compound. And then last but not least, it says, draw a particle diagram for a mixture. So, these questions are basically picture versions of vocab words, okay? So what I want you to do is before you go ahead and answer these, I want you to go back, excuse me, make sure you know what the word element is. Because remember, this is just a vocab question, right? Can you draw a picture of something that follows the definition of what an element is? The other one is a pure substance. I wonder, is there only one answer for a pure substance, or could there be 2 answers for pure substances on that one? Also compound. Is there only one specific thing that could be an answer for a compound, or could you come up with 100 different things that qualify for compound? And mixture, what actually is a mixture? What's the definition? Make that happen in particles here. I'm not going to do that, but we will do that together. I want you to give it a shot, okay? And then next time we're looking at each other, we will either, like this or like this. We'll go over it, make sure that everybody's got that dialed in. Good? But I want you to think about that, because these are the silly kind of questions you're going to be asked on tests and quizzes. Yes, now brings us to this. Last but not least, the flow chart of the universe. This will help you categorize and put everything into the right order so you understand the flow of how things are categorized, right? Matter covers all of it, right? Everything. But matter, if you will recall, comes in 2 categories, right? So, the first category of matter that we're going to have are mixtures, and the other thing is when a mixture is made out of pure substances, right? So matter has 2 categories, mixtures and pure substances. And today, we kind of dug into this thing, the substances. We did this, I'll come back there for a minute. But today we did this, we did the pure substances, right? We covered elements and compounds, right? Elements, all this, the purest form of a substance, can't be broken down by chemical or physical means. All the atoms are exactly the same. And a compound, this is formed by 2 or more different elements chemically combined. Did you catch those 2 main things? Different elements chemically combined. And this, they can go back and forth. Elements can go into compounds. Compounds can be broken down into elements via chemical change. And that's where that right there is where chemistry happens, everybody. Sometimes under a moonlit night, but whatever. That's a whole different kind of chemistry. Now, mixtures that we were talking about. There are 2 kinds of mixtures. You guys remember this? Heterogeneous and homogeneous, right? Heterogeneous being you can look at it and see different pieces. Homogeneous or homogeneous, tomato, you look at it, it all looks the same, right? And it being a mixture, the different pieces and parts are not chemically combined. They're just in the same container, and they retain their original properties. Dig? It's also another thing about a compound over here. Man, compounds, the elements do not retain their original properties. When an element turns into a compound, or 2 different elements turn into compounds, wickedly different things, man. Utterly, totally different. You eat a hamburger. Tell me what happens. Oh, we're done! We're done! Look at that. You guys made it through 2 things of chemistry so far. Only 180 more of these to go or something like that. I don't know. All right, so what I want you guys to do are elements and compounds. A compound problem and elements, compounds, and mixtures. Those are in your homework packet. These are the ones we're going to be working on. So Yeah, I think that's it for right now. Just so you know, what's coming up next are going to be atoms, right? We're going to like dig into atoms. So like we're talking about elements and compounds. These are made of atoms. What the heck is an atom? So what's coming up next is the historical development of an atom, because it's kind of important for us to see and learn how this happened and progressed throughout history. It's not like some one smart person sitting up in a lab somewhere like being a genius and figuring out the universe. This is all of humanity working together over the course of all of human history. So that's kind of what we're going to talk about next time. And until then, we're going to do elements, compounds, that stuff. Toodles.